Well, then let's go to our next speaker. There he is. Our first speaker after the keynote for today is, and I'm gonna butcher your name. I heard the recording, but I hope I'm gonna do this well. Is Maciek Rza. Sorry. His interests are as varied as mine by looking at what you sent us, going from Napoleonic Wars to distributed systems. Today, he will tell us an enthralling story, an enthralling tale about APIs, deployments on Fridays. So welcome, Maciek. Thank you for joining us.
Hello, I'm really happy to be here.
We're super happy to have you here. I think I'll need to leave the stage to you so that you can start. See you later.
See you. Hello, I'm Maciek. It was a Friday evening. It was a Friday afternoon, about 4 p.m., when I saw a green build on our Jenkins pipeline, and I knew that I need to push it to production before the weekend so that on Monday I can see if the bug is fixed. At the same time, I had a very strong gut feeling that it's a trap that I'm setting up for myself. It wasn't a mere superstition about deploys, kittens, and Fridays. Once, in the same project a couple of weeks before, I broke production and I had to stay late to fix it. And believe me or not, after work, I have really better things to do than fixing broken production. So I knew the risk. But why was it so important to ship something on Friday that late? And what was the project about? What gave me the confidence to deploy it Friday afternoon? And last but not least, what was I thinking to test my changes in production? I'll answer all those questions during the presentation, but before that, we need to take a few steps back. I'm a backend engineer at Toptal. At the core of Toptal, at the heart of Toptal, there lays a Toptal platform, or rather the Toptal platform, I should say. It's a Rails application of over 1 million lines of code, and we have hundreds of engineers developing this application on a daily basis. We invested millions of hours in this app. It's a monolith, and yes, it's majestic. And as any majestic monolith, it has its problems. I won't dwell on them because they were described very well in other places. The point is that we are trying to adopt more service-based architecture. And the team when I work, the billing extraction team, is at the spearhead of this effort. We aim to wrap the whole billing code and deploy it as a separate service. And we have to do this. Without disruption of the business operations and without adding too much pain to our fellows from other teams. So what we did was adopting an incremental approach to this extraction. At first, we wrapped billing code in a Rails engine, and we relied on direct method calls to use it from the platform. Then we wanted to check how the real external communication would work. So we implemented this. The asynchronous API was implemented in Kafka. It's really interesting, but I won't be talking about it too much. And the direct communication, the synchronous communication was implemented in HTTP and REST, and that's the topic of this presentation. To make the change safe and to avoid the disruption that I've just mentioned, we added 2 safety features. The first one was a feature flag that allowed us to enable and disable the external calls, the API calls, without deployment and to any fraction of the traffic we wanted. And the second one was a fallback. It meant that whenever HTTP call returned an error, we were falling back to a direct call, returning correct data to the caller. So the request to billing was slower, but it was still correct, even if there was an HTTP error. How the extraction looked like on the code level. Let's consider only two classes, product and billing record. Product stays in platform, billing record goes to the billing service. Product has many billing records belongs to the product before the extraction, but after the extraction, we had to remove those active record associations, but still keep the data associated. So we employed a pattern that could be called active object or something active object-ish. We still had a product that was an active record model, and billing record became a plain old Ruby object. And they were associated using normal method calls. In product, method call was calling billing query service. It was a class that was wrapping all the logic related to external calls, the feature flag, the fallback, the actual networking code. And in billing record, if you wanted to use product, we were doing a database query, as simple as that. So we started extraction with creating a safe deployment environment. We started extraction with creating an environment where we can safely experiment. Besides the standard CI checks that were in place, and besides the easy deploy and reliable rollback, we added two safety features, the fallback and the feature flags, and they allowed us to track how our REST API works. So we deployed it and we enabled it for a fraction of traffic. And yes, we failed miserably. Maybe now, yeah, the performance was abysmal. We couldn't really state it and kept it enabled. We knew that we have to optimize it. And that's when the story begins. What would every developer do? What I would do in this case, I would just start improving the REST code. But fortunately, my fellows was smarter than me. And we decided that we have to use something different. We need something with more flexibility. And that's why in the middle of this radical refactoring of extracting billing, we added a radical step of replacing REST with GraphQL. We added another layer of feature flags to enable the switch, a gradual switch between REST and GraphQL, and to enable switching between the correct REST version and performant GraphQL version on the fly. And we also added the fallback to the GraphQL requests. And with that, we were ready to start, right? Not exactly. We added one more thing to avoid flying blindly. We added custom request instrumentation. That meant that every request that was sent to billing was logged, and we were logging a lot of details about it. It was method name, method from the billing query service, its arguments, the caller stack trace, response time, and if it happened, the error. It allowed us to detect methods that were frequently used to prioritize them. We were able to see the slow methods because we recorded response time one by one. We were also able to recreate those slow calls locally because we had arguments recorded, and we were also able to see which places of the application generate those slow calls or many calls, because we had stack traces. And with this, we had a strong foundation to start the real optimization work. We had good monitoring, so we had good visibility, and we had safe deployment environment. We started the series, like a TV series of optimization. And we started with the most notorious issue, the issue that brought down the REST API. Several views and jobs were generating so many requests that they were killing billing. And what do I mean by many? There were thousands of requests. It was unbearable. Why was that? We were using this active object pattern-ish, and it was really easy to overlook that we were actually accessing billing. So if a job was iterating over end products and calling business logic on every product, if that business logic was using billing records, we had n queries to the billing service because it was hidden in product billing record method. It wasn't very good. So we did 3 things to overcome this. The first thing was moving the data loading out of the product class, at least in this case. We moved it to cache billing record method. Then, inside this method, we were loading billing records for a batch of products, not for a single product. We were grouping those products by billing identifier, and because of that, we had an indexed hash index by product GIDs. And finally, we were assigning those billing records to their respective products. So instead of calling billing every time we were calling business logic, we were calling it once per batch. So instead of n queries, we had as many queries as we had batches. So instead of thousands of queries, we had a dozen. That's definitely better. By the way, if you think that this trick is similar to hash joins in the database world, you're not alone. What we learned here, that if we have a flood of requests that resembles n+1 query, we need to implement the preloading, caching, and joining known from ORM world and from database world by ourselves. And what we also learned is that it's not that hard. What came next? We were quite good at applying those caching that I mentioned before, but we weren't able to apply it in every place, because if we only needed a single field for a whole business logic package, we weren't able to preload the data. But if we were calling this field very often, it wasn't very performant. We had a field that was called about 1,000 times a day, and in the peak it was 800 times per hour. It was too much for us. We wanted to get rid of it. So we coined this smart plan. We thought that we could add this field to Kafka events, modified, emitted by the billing service. Then we could build a projection on the platform side, or the consumer side. And after backfilling the data, we would be able to read this projection, this read model, and we would be able to remove that offending query. That was very smart, and I was very happy that it was me who started to implement this because that was cool. And the problem was that our coworker that has a lot of billing, a lot of domain knowledge, approached us and said, guys, we could do it in a better way, because maybe we have this data in our local database on the platform side. I must admit that I was a little bit angry, because I was working on the smart solution with Kafka and building projections. And if you build something like that, you can even talk in a conference about this, right? And here we have a boring solution with a local DB, but we started checking. We built a few big database queries. We talked to other billing developers, to product people, and we realized that indeed we have this data. So we replaced the external query with a simple database query fetching only one field. And instead of spending 2 weeks on this smart Kafka solution, we spent 2 or 3 days on querying the database and talking to other people. And we had a working solution that solved our problem. And also our solution was more maintainable, That's the one with Kafka. What we learned here is that while the cool technical tricks could allow us to win optimization battles, domain knowledge can allows us to avoid those battles at all. So we did all those tricks related to smart caching or using local data, but what came then? We had very big responses that were slowing down the whole billing because of the other requests were waiting for those responses in the queue. Why was that? We wanted to have at the first place, we wanted to have a minimal API with generic responses. So we were returning every field that was possibly needed on the platform side and every association that was probably needed on the platform side. It meant that we were returning about 40 fields and 3 to 4 associations. It meant about hundreds of associated records very often. To make it even worse, we were filtering data on the client side. So we were pushing through the network a lot of completely unneeded data. And that was the moment when the fact that we decided to switch to GraphQL really paid off. That was the moment when GraphQL really shined, because we were able to build custom queries in a very easy manner. After implementing the types on the server side, we were building queries on the client side without changing the server. And in this case, instead of 40 fields, we chose only 4. And we also added server-side filtering, and the life was really good. I must admit that I really liked this optimization project because we were in this tight loop of checking the monitoring, prioritizing, choosing something to optimize, and then pushing to production, enabling the feature flag, and seeing, yes, it's faster. That tight feedback loop was really rewarding. And I thought it would be the same in this time. By the way, do you remember what was the hottest day last summer? I do. It was 28th of July. I deployed my changes and I enabled the feature flag, and I was watching Slack. Someone told that there are problems with Sidekick workers, too much memory. I thought, poor infra guys, they have to tackle it. Someone told them that there are problems with staging deployment. And I thought some developer was really reckless to push something not fully tested. Then someone told me personally that maybe it was my build. I didn't believe, but I started checking. Then some business users told us that there are issues with platform, so we switched off the feature flag on my changes just to be sure. But the next step was that someone told us that the platform was down. How bad was this? It was really, really bad. The CPU usage was 20 times as high as usually, and memory usage was 20 times as high as usually. We were consuming dozens of gigabytes of memory, and we didn't know why. And to make it worse, we had Postgres queries that were running, that were taking minutes. It was really, really bad. And I realized that it was my build, and I felt cold sweat on my back. 28th of July was the hottest day last summer. But then two things happened. The first one was infra intervention. People from the infrastructure team reverted the offending build quite quickly before I even realized that it was my fault. And they returned the normal business operations on the platform. That was great. And then when I stayed late to revert my changes on master and deploy the clean master again, they assisted me and they really helped me. So I was never left alone with my problem. That was a really great experience. And the second good thing that happened was my manager. They came the next day, assured that I'm working on the fix, but he didn't reprimanded me for breaking production. Actually, he congratulated me, to my surprise. And he explained it that while it's not okay to break production, it's okay to make mistakes as long as we follow up. And that's also the part of our safe deployment environment, the soft part. It's okay to make mistakes, right? So it's okay to make experiments. That was really good. So what really went wrong? Two things. I did a small refactoring on the REST branch of my code. I added parameter sanitization, and I sanitized too much. I allowed only one parameter. And then on the server side, that was this old method waiting that was quite optimistic and waiting to cause problems. It was accepting a couple of identifiers for billing records. And if identifiers were present, it was adding where clauses to the scope. But if there were no identifiers, nothing was added to the scope, and we were fetching all the billing records. So if someone asked for billing records for a client GID was filtered here, nothing came here. So billing records method in the billing service was fetching all the billing records with all the associated records, almost the whole database, millions of records. That was pretty terrible. The fix was simple. Besides, of course, fixing these parameters sanitization, I added also a safety check to billing records. If nothing is passed, we'll return nothing, period. Why wasn't it caught by my unit tests? I had unit tests for this, but only for this single param. Why not the feature flag? Because when we disabled the feature flag, we came back to the safe REST implementation that actually was buggy because I added a bug there. So that's the whole story in one picture. We started with this slow API. Then we have this chasm when API was switched off on the feature flag, and I was working on a fix. And then after deploying my optimization, the API is not only faster, but also more predictable. We don't see this big sol here. So it's definitely better. And we did it through custom queries, through underfetching, and through moving filtering to the server side. What I really learned here is that even though I trust my reviewers, I trust myself coding, I trust my unit tests and my feature flags, I should always test manually. In this case, in the section of pull request asking how to test, I wrote trust the specs, and it was a mistake. What I should have done, I should have prepared a simple test, manual test scenario, even in the console, that could help us to detect this issue. But it was overcome, and we managed to increase the traffic handled by external calls even more, and we were noticing a strange issue that happened only on Sundays. There were 4 to 9 too many requests errors in our rollbar. So because it looked like a request flood, it was really easy to fix, right? Because we just implemented caching that I mentioned before. And we deployed it, and we waited for Sunday, and on Monday we saw the same error. Why was that? The issue was that we were sending reminders that were scheduled on Sunday, but they were also sent on Sunday evening, 5 p.m. and user time zone. We knew about this, but we thought that if we put it in the user time zones, there will be 24 buckets, and we'll handle that because we'll spread the load. The issue was that 1/4 of this kind of users lived in a single time zone. So when 5 p.m. at this time zone came, we saw this error. We couldn't move our user to different time zones. So we moved our reminders. We spread them over 120 seconds just to avoid overloading billing. We deployed it and we saw the same error on Monday. So another week, we realized that we forgot about another reminder. So we fixed it, waited till Sunday, and then we saw the same error. Why was that? Sidekick, at least the version we were using, had was polling Redis not very often, every 15 seconds or every half a minute, not every second as we expected. So even though we scheduled those reminders correctly, they were executed more rarely than we thought. And instead of executing reminders in 120 small buckets, we were executing them in 5 or 8 big buckets. That was killing billing. That wasn't very good, but this time we were at Enterprise. We took Sidekick limiter from Sidekick Enterprise, and we implemented a proper client-side rate limiting. And this time we waited, and on Monday there was no errors. That was great. Note that we spent over a month on working on this, and we could do this because of those safety features we had, or because of this safety fallback that even though we saw this 4 to 9 error, we were returning correct data. And it was during this long optimization saga, this 1 month, when I saw a green build on Jenkins on Friday afternoon, and I decided I need to deploy it. And I really deployed it, and I went home. And even though the first time I did it, it didn't work, I was safe on the weekend. And I must admit that I did it twice, at the very beginning of this saga, and at the very end. Those two wrapping changes were deployed on Friday afternoon around 4, and both of these deployments were safe. So we built, and there is one more thing to say. This triad of monitoring, optimizing, and deployment allowed us to iteratively prepare our API for full production use. So when we enabled external calls to 100%, it was completely unremarkable. I don't remember when it happened. I remember that we were glad that it works correctly, but it wasn't like this old Wild West deployment when we have a firefighter team waiting for a crash. It was a safe change, and it just started working. We built on good visibility with monitoring, on safe deployment, and because of that, we were able to apply a couple of optimization patterns. That was preloading to avoid N+1s, moving, filtering to the server side, and fetching only the data that was needed, using the local data when it was possible, and spreading the load. And when you take a look at this list, I believe that those are not new tricks for you, right? Either you use them in the microservice world, or maybe you see it in some other places, because preloading to avoid N+1 that we used in GraphQL, it's in every ORM, right? Server-side filtering, we use this a lot in the Rails world by moving something to the database. We moved here to the producer side from the consumer side. With using local data, it's a no-brainer for any browser developer to avoid requests that were not needed. Under fetching, that where the place where GraphQL shined is widely known from SQL. And about adding jitter to spread the load, I read about 10 years ago in a post about YouTube architecture. So why do I bother with this story? Why couldn't we do it right from the beginning? The answer is threefold. First of all, it was about simplicity. We started with a boring solution, with REST and with the minimal generic API. And only when it was needed, we were implementing something fancy. Secondly, it was about learning. we realized that during refactoring, it's really hard to spot performance issue simply by staring at the code or running unit tests. In some cases, you need to apply production shape, the traffic of production shape to your code to see the issues. And that's where the safe deployment strategy helped us. And the last but not least, it's all about trade-offs. To name only one of them, when we were adding jitter to our reminders, we had to convince one of the feature teams in the company that we need to do this because they want to send the reminders at the exact time at 5 p.m. And we had to explain them that it's actually not possible anymore. So we shared with you what we learned. We shared with you our tricks and our patterns. We shared with you our mistakes. So now you don't have to repeat our mistakes because you can use our findings. Instead, go back to your work, make your own mistakes, and come back to us with your findings and share them with us so that we all learn from you. And if you wonder if your environment is safe enough to experiment, just think how you feel about deploying to production on Friday afternoon. Thank you.
And we are back. Thank you, Maciek. This was a roller coaster.
Yeah, it was a roller coaster for us as well. I love this project.
Yeah, when I heard about, like, oh, which day was the hottest, like, something is coming.
Oh yeah.
But I really appreciate how much you have shared about, failure. It doesn't happen as often as I wish it would, because everybody, especially newcomers, are like, oh, everything has to be perfect. And this also happens actually to people with more experience, like, oh my God, I failed. But that's how we learn, right?
Yeah, that's right.
If we never fail, we never stretch ourselves in places we should go, actually.
Yeah, I agree totally.
So thank you so much for sharing your experience. There's already one question. Luca is on a roll today. Is there anything else that you would have done differently?
Is there anything else I would have done differently? Let's say that we have infinite time here. That's really hard, right? I would implement. I would copy the production infrastructure locally to be able to apply this production-like traffic locally. And I think that we would be able to fix some of the issues more quickly. We had a lot of the parity between dev and prod, but in some cases, those 4 to 9 errors were not raised by the Rails application, but by the proxy, by Nginx that was in front of it. So to reproduce it, we would have to rebuild the same. We would have to rebuild the same infrastructure locally, and we didn't because of the time constraint.
Yeah, time, usual problem.
Yeah, even the cool technical projects have some deadlines. So that's, as I said, it's all about trade-offs.
Yes, exactly. Everything is about trade-offs. That is so true. That also comes a bit with experience. I was very frustrated at the beginning when there was it's like, oh, that's those are deadlines. So like without deadlines, there's no point if you don't put that stuff out there, right? Like, why would you even build it?
Yeah, that's right.
I am curious because so for behind the scenes, for the people out there, because we don't know if there will be any questions, we prepare some questions in advance for our speakers. And there was one in which I'm seriously curious. Was any kitty armed during the Friday deploy?
We don't have a certificate for this, but I am sure that no kittens were harmed. We take care of this, and actually, I plan to implement a special CI checks, this kitten safety check for this.
Very well done. My kitten that is sleeping there in the corner, not everybody sees it, is approving of that. So you'll get some credit. Oh, there's another question by Tiago. How are the features planned? Is there a general discussion with the team before defining how it is going to be implemented and how detailed that is, if there is one?
Yes, we do discuss it with the whole team. Usually, someone is responsible for creating technical stories, one of the developers, and prepares a plan for a change, and then we discuss it with the whole team. I guess that the question is why Samuel had to came late and point out that there is a better solution. We are not very strict about everybody attending all the meetings. People go to holidays, people take times off. So in this case, we realized a bit late, but still at the beginning of the implementation, so it wasn't that bad.
Okay.
Regarding the details, it is up to a developer to provide the implementation, but then it's discussed again during code review.
Okay, so you have these conversations during the code reviews. Do you happen to have I don't know, like design documents where some conversations happen earlier, validating the architectural approach, things like that?
On the very high level, we do have those documents. In this case, in most cases, we didn't. We had a high-level discussion about the GraphQL migration, about the feature flags, but then a lot happened during daily meetings and in ad hoc basis.
Okay, yeah. That is something that I'm still trying to wrap my head around, because ideally, like I would like to have design documents, but especially with tools like Slack, for naming one, but HipChat is another one, or Microsoft Teams, you name it. A lot of those conversations do happen in other places, and then how do you keep your documentation and design documents relevant while still not completely hindering the team in the free flow of creativity, because that's what the job is also about.
Yeah, that's true. Finally, the code is the ultimate source of truth. And regarding the non-executable parts, it's the place when we need to realize that our work is not only coding, and someone has to maintain those documents if they are leaving documentation. And it's not a very revealing things to say, but I often forget about this, that there is an effort to be made in maintaining the docs.
I mean, again, it's partially it's because we are humans, and of course, recency and things like that do happen. Like the daily grind happens no matter what, right?
Yeah.
And my team, we are experimenting with having a documentation owner. This is not the person that writes the documents or that documents everything that we say or that we come up with while implementing the thing. But it's someone that ensures that documentation is written. And they are responsible for being the bad cop if if at the end we don't have that knowledge documented somewhere outside of the ticket, the channels, or whatnot.
Yeah, that's smart.
Yeah, it's kind of working. It's an experiment.
What we also do at the company is that whenever we come up with something that's novel or at least interesting, we write a blog post. We had a big engineering team, so it's a really good way to radiate the knowledge. Actually, this talk started as an internal blog post and then
That's cool.
Grew big.
Oh, that's interesting. I know that some companies are also using an RFC-like process.
Mm-hmm.
Have you tried anything like that?
Yeah, we do have this, but on another level.
Mm-hmm.
With big architectural changes, we start with RFC, we collect feedback, and then we promote this as a standard.
Okay. Yeah, it also depends how big the change is, right? Like if it's a
Yeah.
fundamental change, then you want to have a more thorough process, also invalidating the idea. And if it's a smaller change, like a feature or something like that, it's much more nimble to just go with the flow.
Mm-hmm.
Do you have time for another question?
I do. I have all the time in the world.
I'm gonna steal one of yours. How come that the error that put down production came through all your defenses? CI, reviews, feature flags.
So one by one, I was trying to actually answer this question in the presentation in this run. It it came through the unit testing because I was testing this single param that was sanitized properly. From time to time, I don't test all the cases, just some of them if all of them looks similarly. Then the review, staring at the code is not the best way to spot subtle bugs. And regarding the feature flag, it could have saved us if we knew what was happening. If we switched fully to GraphQL, we would save the day, and someone would have been a hero, maybe me. But instead, we switched to something that was considered safe, to REST, and we made it even worse. That's why I can tell this story. Yeah, bad decisions make great stories.
Yes, they do. They do. We did a couple of times, like for bigger incidents, we are starting to have this practice of postmortems.
Mm-hmm.
Do you also have something like that?
Yeah, we have it. After implementing the fix, I spent probably a day to collect all the data and write a postmortem to share it.
You
With
did
our
it
team.
yourself. That's cool.
Yeah, I had time for it. Yeah, we had some time constraints, but it's not about quality or sharing knowledge.
Yeah. Okay. Sounds good. I don't have any further questions. I don't see also any other questions beside a very smart comment. Don't fuck with cats. Yes, that's true. Well, then I wish you a great day. I hope you'll join us in the hallway and
Of
in the
course,
next talks.
of course.
Thank you
Thank
so
you.
much for sharing your experience again. It was great to have you here.
Yeah, I'm happy to be here. Thank you.
Thanks.
Bye.